Speaker view. Yeah, cool. Okay, hello everyone and welcome to the National Space Academy Takeover Week. We have taken over the National Space Centre's YouTube channel. We are talking to some really cool people from the space sector, all about how they got into their job and the things that they like to do. My name is Nat and I am here today with Dr. Natasha Stephen from the University of Plymouth, and she is an expert on meteorites. Hello Natasha, how are you doing today?
Hi, thank you so much for having me.
No, thank you for being here. It's so kind of you to give up your time. I know we were just discussing that you have a backlog of meteorites that you need to analyse, so I know your time is precious, so we really appreciate you being here today. I was just wondering, could you start by just telling us a little bit about what you do?
Yeah, sure. I have a couple of slides actually to help sort of tell my story and set the scene. So I will just share those now for you. So my career really, I'm what we would call a planetary geologist or a planetary scientist. So I work on extraterrestrial samples, so samples that have originated from outside of the Earth. So that might be from Mars in the case today, it could be asteroids, it could be from somewhere else entirely, it could be from the moon. And that means we get to look at a lot of different specimens, which is a really exciting field to be in. But it's one that not a lot of people know about in terms of, how do you get there and what your career path is. So I thought I'd share a little bit about how I got to what I'm doing today, because I appreciate it's a little bit unusual. So I trained as a geologist. I was one of those kids on the beaches, when they're really little, going around and picking up every rock, every fossil, every mineral, wanting to take everything home with me, my poor parents. And they encouraged me when I was really young, and really I never grew out of it. Kids always like dinosaurs and volcanoes, and some of them grow out of it and some of them don't. The ones that don't grow up to be geologists. So I did A-level geology and I did geology at university. So in your studies you're taught to think about the Earth as a whole system, so the different cycles that make up the Earth and life on Earth, so the water cycle, the rock cycle, and how all of these things interact with each other, how they formed, how they originated, and how they've evolved through time. And that's really important as a geologist, because you're talking about 4.7 billion years of history, and the Earth looked very, very different 4.5 billion years ago to what it looks like today. And it's constantly changing, even on a daily basis. So when I got to my master's stage, I was really fascinated with the volcanoes. I really didn't grow out of it. And I'd done a master's project in volcanoes on Iceland, looking at how they'd erupted and how eruptions had changed through time. But I was still thinking about, as a little kid, wouldn't it be cool to be an astronaut? I think everyone goes through that phase. And obviously that's not always realistic for everybody, but could there be another way to explore the solar system? Well, I learned at that time that there are actually volcanoes elsewhere in the solar system, so not just on Earth. And this image shows a couple of different volcanic hotspots throughout the solar system. So our planetary neighbours, Venus and Mars, either side of us. So you can see Earth is the one with the beautiful blue sky. Venus and Mars, either side of it, have got volcanoes. But also some of the moons around Jupiter and Saturn have got different types of volcanic activity as well. So there's quite a lot of exciting volcanism happening throughout the solar system. So I decided to focus away from terrestrial volcanoes, and I didn't want to look at Iceland anymore. Everybody was looking at Iceland and Hawaii and Etna. Let's go and look at some more exciting volcanoes, and decided to focus on Mars. So Mars is one of our neighbours. It's not our closest neighbour, that's Venus. But Mars has got some really cool volcanoes on it. And in fact, those volcanoes are really spectacular on Mars. This is the largest volcano anywhere in the solar system. This is Olympus Mons. And Olympus Mons is so big that when you look at the whole volcano in an image like this, you can actually see the curvature of the planet behind it, which is quite unusual. And in terms of scale, Olympus Mons is actually quite a lot bigger than anything we have anywhere on Earth. Mount Everest, Mauna Kea, it's actually almost 3 times the size of Mount Everest. So this really is a massive, massive volcano. So the volume of volcanic rock that makes up this volcano as a geologist is really exciting. And it's not the only volcano on Mars either. So as a geologist, I've kind of been trained to think about the Earth as a system, but actually you can expand that thinking even larger and then consider the Earth as part of a larger system, the solar system, and all of the different planets that have evolved largely through the same timescale, but have gone in completely different directions. So what are the common features we see throughout the solar system? Where are the other volcanoes? Where's there water? Where are there rivers? Where are there canyons and mountains? And we can start looking for comparisons. So I didn't get to be an astronaut directly on the surface, but I did get to go and do a PhD at the Natural History Museum, which is another training degree after your undergraduate. It's called a postgraduate degree. And you get to go and study for your doctorate. So I got to be a doctor of Mars meteorites. That's what my research field is. So I didn't get to be Harrison Smith on the surface of the moon, but I did get to work with geologists like this. So the Curiosity rover, which landed in 2012, 2013, the mission launched and landed, is a robotic geologist. We don't have people walking on the surface of Mars, but we do have robots doing it for us. And it's not just Curiosity. There are lots and lots of Mars missions. We've been exploring Mars for a really long time, since back in the 1960s. And it's really exciting because just in the last fortnight, we've got 3 new missions that have joined the Mars family. We've had the Chinese Mars mission Tianwen-1 that went into orbit around Mars 2 weeks ago, and that has a rover that's going to deploy onto the surface of Mars in May, so that's not even done with being exciting yet. We had the HOPE mission from the Emirati Space Agency that went into orbit and is looking at the Martian atmosphere. And then, of course, we had the NASA Perseverance rover that landed just the other day. And if you haven't been looking at these stunning images, you need to go and look at them. And there's a fantastic video, which I'm not going to play all the way through, but you do need to see this. This is possibly the best video that's ever been made of anything ever. And I'm going to skip forward a little bit so you can see the live footage from 3 different angles of a rover landing on another planet. It's just absolutely phenomenal what was managed to be achieved here. So these Mars missions have been going on for decades, and they're getting bigger and better, and we're learning more and more about the red planet's atmosphere, its surface, and how that has changed through time. But none of these missions have yet brought back samples for me to be able to look at as a geologist. And that's really sad, because we like to have our hands on rocks, we like to go on field trips, and we can't do that with Mars. It's not viable at the moment. It will be in the future, but not quite yet. So we have to rely on a natural delivery method called meteorites. So meteorites are the product of a fireball or a shooting star. I'm sure lots of people in the audience have seen a shooting star in the night sky. The fireballs are events that are a bit bigger, and they're so bright that you can see them even in the middle of the day, like you can see here. And if you're really lucky, you can find the meteorite, the solid object that landed as a result of that fireball event. And these are the things that we get to study. So this is a very famous Martian meteorite. This is the Tyson Martian meteorite, which is on display at the Natural History Museum. And this is really personal to me because this fell, it was seen to fall and was collected whilst I was doing my PhD. So I got to be one of the first people to actually study this meteorite and look at it with X-rays and try and work out what was going on. So how do we find them? How do we get them? Well, if you're lucky, you can see the fireball and you can go and find it. But sometimes you just have to walk around and keep everything crossed that you're lucky enough to find them. So we go out looking. One of the things that I get to do with my job is travel a lot, and I get to go on what we call meteorite hunting expeditions, but we're not really hunting them. We're hoping to find them. So meteorite recovery might be a better name for it. And we get to walk around deserts. So whether they're hot deserts or cold deserts, where you have an environment where everything in front of you looks exactly the same, something that's fallen from space and landed on the ground is normally quite obvious. So we get to go out every year, other than the COVID period that we're in now. We would normally go every year, and we go out hunting to the Australian outback. So we go out to the Nullarbor Plain, which is in South Australia, hundreds of kilometers away from anything. We drive out in a team of us, we take everything we need, we just camp. So it's sort of 2 weeks, no showers, cooking on a fire. It's a great experience. You either love it or you hate it. And we just go out walking every day. And this is the type of terrain that we have. You just walk for anything between 10 and 20 kilometers a day, walking around, hoping to come across a meteorite. And if you're lucky, you'll find one. And here's my first ever meteorite I found back in 2016. And this is a meteorite that's just sat on the sand. You can see the grain size there, me holding it for scale. And that's the really exciting thing, because you found something, but they don't come with a little GPS tag on them saying where they came from. They don't come with a label saying, please return to. So when you find a meteorite, you don't actually know where in that solar system and all of those different planets it's come from. You're kind of starting at the end of the story and you have to work backwards. And that's what makes it a really exciting research field. So we don't all get to be astronauts walking around on the surface of the moon, but by exploring the meteorites that get delivered to us naturally on Earth in the lab here, we can start trying to explore that solar system around us. And I think we're going to go to a Q&A.
No, that's great. Thank you so much. So when you are out looking for meteorites, is there anything in particular that might tip you off that it's from Mars in particular? Is there anything you actually look for?
It can be really hard to tell whether something has come from a particular place whilst you're out in the field. So there are a couple of telltale signs, particularly for Martian meteorites, and that's because we've got about 65,000 meteorites that we know about here on Earth. And of those 65,000 separate meteorites, just like this one here, only about 200 of them have come from Mars. So they're incredibly, incredibly rare. There are lots of very common types of meteorites, and Martian ones are not. So the Mars ones are quite distinctive because this is a common meteorite called a chondrite. And if you look at the outside, you can see it's very dark. And that's because as it's traveled through space, space is very cold, but as it gets into Earth's atmosphere, our atmosphere is really warm. So it sort of superheats the outside of the rock and it melts slightly. So we get what's called a fusion crust on the outside, which is this kind of brown, dull structure. But in a Martian meteorite, unlike these really common meteorites, these ones have got metals in them, so they're really quite dense. But Martian meteorites typically have very, very little, if any, metal in them. And because they're all rocky, the melting happens, it's melting and it goes to glass. So we get a really black, shiny fusion crust. So if you have metals, you tend to get a browny red. But if you don't have metals, you get black glass. So if you get a black glassy thing in the desert, that's really exciting because that's potentially a Martian rather than a chondrite.
Oh, that's great. Thank you so much. And so Mihaela has asked us, what minerals would you find in a meteorite from Mars?
The ones from Mars are usually, because Mars is a very volcanically developed place, the whole surface of Mars is covered in old volcanic rocks. So the minerals we find in meteorites from Mars are really similar to the minerals we'd expect to find in a volcanic rock from Iceland, like I studied in my master's, or Hawaii or Etna. So the minerals are typically what we call rock-forming minerals, really, really common. So things like olivine, which is a type of magnesium silicate, pyroxene, which has some calcium, some iron in there as well as magnesium, and other minerals as well, like feldspars, chromite, ilmenite, spinels. So nothing unusual. We tend to see a lot of these minerals here on Earth if we're looking at volcanic rocks here. It's just that those minerals have formed in a volcanic system elsewhere in the solar system.
Great. So do you think then, one of our space engineers, Finley, has asked, do you think it's possible for meteorites to contain new materials that we've never seen here on Earth before?
Absolutely. We have lots of minerals, actually. So we're discovering new minerals all the time. Some of them we've known about for over 100 years, but new minerals are being identified and classified all the time. And there are types of minerals that have been identified in minerals for the first time. So the type specimen, the first one that's ever described, is often found in a meteorite. So from Martian meteorites, there's a type of mineral. So it's not an entirely new mineral, but a type of mineral that can only exist in Martian meteorites because of the impact required to knock these materials off the surface of Mars. It creates a sort of a shock metamorphism. So it's intense heat and intense pressure for a really short amount of time. And it creates like a shock wave that causes some of the structures in the minerals to change. So we start to see phases like that. And then there are other completely new, unidentified on Earth phases that we see in some of the other meteorite groups as well. So yeah, absolutely, we do find new materials all the time.
Oh, great. Thank you for that answer. And so Mike has asked, would you, if we fast forward a few years now, so we're looking at the missions that are starting to bring samples back from Mars, Mike would like to know, would you hope to be part of the team that analyses the potential sample return in 10 years' time or so? Absolutely. So the Mars 2020 rover Perseverance that just landed last week is the first step in a series of missions. It's an international collaboration between NASA, the European Space Agency, Canadian Space Agency, Roscosmos, lots and lots of different space agencies. So the Perseverance rover will be driving around with a small drill to actually create sample tubes, but put samples in tubes and then keep them all together for another rover to go in the 2030s. And that rover is going to go around and pick up all these tubes and then bring them back to a little rocket on the surface of Mars that's then going to eject them back and then get picked up in space and bring them back to us. And that process is only just starting. So anybody currently working in the field gets to be part of that sample sort of analysis team. And of course, this is going to be going for the next 20 or 30 years minimum. So all of the people that are really inspired by this Perseverance mission who are in school today, they can get into training. They can be there ready to be the first person receiving those samples when they come back in the 2030s, because we're still talking about 15 years away from now at the least. It's such an exciting time, isn't it, to be part of this Mars science analysis. I think there's so much going on, especially at the minute. It would be such a good time to get into it as well. And so if we fast forward a little bit further, quite a lot further, probably. And if we start to think about maybe potentially living on Mars, Moyes, one of our space engineers, would like to know, if we were to move to Mars in the future, how could we protect ourselves from meteorites when we live there? Would Mars's atmosphere be enough?
That's a really good question. And no, Mars's atmosphere is not enough at all. So Mars's atmosphere is really thin compared to the Earth's atmosphere. It's also quite different. It's mainly carbon dioxide, so we wouldn't be able to breathe it anyway. But assuming we've got the right equipment to be there, we'd have to protect ourselves from meteorites impacting, because Mars's atmosphere, we think today, is probably only 2 or 3% of what it used to be. So it's very, very thin, which means nothing gets slowed down really. You know, we've seen what happens with the rovers. They need parachutes and then sky cranes to lower themselves down. And if you look at some of the satellite imagery that we have of Mars in the last few years, you can pick an area on Mars and look at it from one year and then look at exactly the same site the next year. And we've got evidence of brand new, fresh impacts into the surface with new craters that didn't exist the year before. And you can see all the ejector material. And of course, the rovers have found meteorites sat on the surface of Mars that have hit the surface of Mars and are continuing to do so today. So absolutely, we would need to protect ourselves in some kind of environment to be there, because it would be a risk. Thankfully, the likely impactors are much smaller today than they used to be. We wouldn't have anything that creates these huge craters that you see from space anymore. They typically tend to be a lot smaller. But yeah, absolutely, there's a big difference in Mars's atmosphere.
Fantastic question there from Moyes. Just a reminder, if you have got any questions, you can comment them in the YouTube channel, so please get them in if you have any for Natasha. So moving slightly away from what you actually do now, how did you get into the field? What made you decide that you wanted to be a meteorite specialist, and did you always want to be one?
I definitely didn't always want to be one. I didn't always know what a meteorite was, of course. So as I said, I was one of these kids that always just enjoyed rocks and fossils and minerals, and kind of grew into the volcanoes and then decided to look at extraterrestrial volcanoes. But I think what was really important for me was when I was at school, I was always really into sciences, and I had some really enthusiastic teachers who really wanted me to go to university. But, you know, I'm kind of a first generation university student. I come from a really, you know, working class background, bog standard education, no private schools or anything. And no one else in my family had ever been to university. I was the first one to go. So I didn't know that it was possible. Even when I started university, I didn't know it was possible to stay at university and do another degree. I didn't know that you could get a doctorate. I'd never met anybody that had a PhD. I didn't know what it was to be a doctor of rocks. So that was something that I learned just by talking to other people when I was at university. And lots of people knew it already, and I felt a little silly for not knowing. But I was excited, so I just asked lots of questions. And I think that's probably something I haven't grown out of. I still ask lots of questions all the time, whether I'm supposed to or not. But I think it's the way that we learn. And, you know, you never get to a point where you're an expert in something and you know everything there is to know about your subject. There's always more to learn, particularly in the space industry, because only, you know, so much of this is only now possible. The industry has come a really long way in a really short period of time. You know, you talk about 100 years ago, nobody even ever dreamed of doing this. And it's only been in the sort of last 60 years that we've really got to a point where these things are possible. So I think there's a lot more to discover, and we have to just keep asking those questions. So no, I absolutely didn't always plan to do this. I always liked the idea of being an astronaut, and I always liked the idea of being a geologist, but it never occurred to me until relatively recently that I could combine those things and get to do them in the lab.
So if there was someone perhaps in your position, in that they were looking to go to university for the first time and they didn't quite know what they wanted to do, but they had a vague idea, vague interest in the space sector perhaps, what piece of advice would you give them?
Try and talk to people. And I know that can be really daunting and that can seem really hard, but most people who work in a sector like the space sector or any sector are really passionate about what they do, and they're almost always willing to talk to someone. They might be really busy and they might not be able to drop everything they're doing exactly there and then, but they'll normally try and find time to talk to you about it. So whether it's, you know, you just quickly Google the topic that you like and find a couple of names and email addresses and just email them. Or if you use social media, there's loads of people through things like the National Space Centre and the National Space Academy, where you've got lots of sort of representatives and people who are willing to talk, and you can find lots of Q&As and loads of people that are sort of putting their face out there and their names and their contact details, so you can just have those informal conversations. And, you know, I always send emails say, this might seem like a stupid question, but I still ask it, and it might be stupid to them or to me, but it's the only way that we learn. So don't ever feel like you're not able to do that. If somebody doesn't have the time to dedicate to you, they'll normally try and find somebody else that can. In my experience, that doesn't happen. People are just really excited to tell you about what they do.
And so Mike has made a really nice point in our comments. He said it's fantastic that the fact that you're in Plymouth and studying Mars, a lot of people think that you have to work for ESA or NASA to get involved in this. So I just thought that was a really nice point. But I know your job involves a lot of collaboration with people all across the world. Is that something that you enjoy?
Yeah, it's probably my favorite thing about the job. So being in Plymouth, for people that don't know where Plymouth is, it's right down in the southwest of England, at the very, very bottom of the UK, sticking out into the Atlantic Ocean. And there aren't any other planetary scientists, there aren't any other space people down here, it's just me. But the world that we live in today, with things like Zoom and YouTube and all of these online meetings, you're able to collaborate internationally. So it doesn't matter where you are, it's about having those connections and that network of people that you can work with. So I work regularly with collaborators and colleagues and friends at NASA over in the US, so California and in Texas, but also going the other direction in Australia too. So I have lots of colleagues that work out there because of the meteorite hunting. We go out there every year. So suddenly it doesn't really matter geographically where you are. Space is for everyone and it's literally all around us. No one can lay any claim to it. So it doesn't really matter where you are on Earth. You're still on Earth, which is this tiny little dot in, the bigger system. So yeah, it's all about those networks that you can have, and it leads on to travel opportunities, which is fantastic. So when we are able to travel, being able to go around the world and share what you're doing with other people, share samples and learn from each other is a really, really cool perk of the job.
Yeah, I think travel is something that certainly seems to interest quite a lot of our space engineers. So is that a big part of your job, and has it always been?
Yeah, I think so. So from when I started my PhD, my doctoral degree at the Natural History Museum in London, I got to travel a huge amount. So scientists who are working in a professional environment tend to have annual meetings where they can go and collaborate internationally. And that meeting will tend to hop around the globe. So my first one was in New York, and then there was one in Texas, but we've also been to Morocco, Canada, Australia, Japan. So you really get to travel around. So, without really trying very hard, you're suddenly on 5 or 6 different continents just by doing your day job, because sometimes you need to go and present information in a different environment. And then the best thing about it is once you've been doing it for a while, people see who you are, they hear about what you're doing, and they invite you. So recently I've been able to go to Japan, I've been able to go to Germany a couple of times, and people sort of make that opportunity available to you, so you don't have to pay anything for yourself. Other people are putting that opportunity there, and you get to benefit from that. So travel is always there. It's not a requirement, it's an option. So if you don't like travel, or you're not able to travel for one reason or another, it's not going to prevent you from doing anything, especially in the digital world. If COVID has taught us anything, it's how much we can do these things without physically leaving a normal space that we live in, even to do our day jobs. So yeah, so travel is absolutely an opportunity, but it's not a requirement.
So I think even just talking to you in the last 20 minutes, I could probably pick out about 10 things that I think are really cool that you've done. But what do you think? What is the coolest thing you think you've ever got to do through your job?
That's a really hard question to answer. It's all relative, right? So every time I have new students that get to come and work on research projects, the first thing that they want to do is get all of the meteorites out and say, okay, so in this hand, I'm holding a piece of Mars, and in this hand, I'm holding a piece of the moon. And isn't that cool? Because no one ever gets to do that. But, when you do that every day, when you're looking at these samples every day, that becomes less cool to you, relatively speaking. So for me, it's probably still going out and recovering meteorites, because when you find one, like the ones that we find in the outback in Australia, you might be the first human being that has ever seen that sample. It could have just fallen yesterday. It could have been there for 100 years. It could have been there for 1,000 years. And you were probably the first human being that's ever encountered it, and certainly the first human being that ever knew what it was to pick it up and take it away with you. So that's probably the coolest thing about my job at the moment.
Sounds pretty cool to me. And I have to ask this question, I've been asking everyone, given the chance, would you go to Mars to do your job?
Yes. Do I get to come home again? I should probably ask that first, shouldn't I?
I think you're the fastest person to say yes, and then think after that, maybe. So is
yeah,
that That's something you definitely want to do.
Yeah, if I was given the opportunity, absolutely, it would be phenomenal. You know, everything that I'm doing in the lab, I'm looking at samples that I know have come from Mars. I'm trying to work out where they've come from on Mars, but to actually go and to be able to stand there, pick something up and say, yeah, I was right. That matches what I've been doing back there on Earth. You know, be able to have that context that we just don't have would be fantastic. The rovers are great, but they don't go very far. They're only looking at very, very small places. So to be able to go and actually walk around on the surface a little bit quicker than the rovers do would be really phenomenal.
And what about eventually moving there? Would you ever consider that?
Oh, I don't think that will happen in my lifetime, unfortunately, but it would depend. It would depend. If it was stable and it was safe, then absolutely, yeah. But I don't think that's in my lifetime, unfortunately.
It's quite a long trip home to visit as well, isn't it? I suppose. So
you have to plan in advance for any big events. Yeah.
Yeah, you would. So just to sort of summarize and finish up then, I know we touched earlier on a piece of advice that you'd give, but is there anything else you can recommend that young people could do to make themselves stand out when they're applying for jobs, when they're looking for what to do next, or any pieces of advice?
I think always try and talk to people beforehand. So if you're applying for a job, or you're applying to university, or you're applying for a research project, maybe, you know, for your degree, don't do it that blind. Don't just do the application. Try and get in front of the person, so whether that's physically in front of them, you know, knocking on the door saying, hey, I see you're advertising this, I'm really interested, can I have a chat? But if you can't do it physically, always try and send an email or have a telephone call, and all you have to do is say, hey, I saw this, I'm really interested, can we talk about it? And that can be a really superficial conversation. Most of the time people want to know why you're so enthusiastic about something, because your CV and your application tells the person everything they need to know about your skills and whether you're qualified. But the enthusiasm is often more important. So when I have projects that are advertised, I get lots of students that are really interested, and you can always tell who's going to end up doing the projects, because they're the ones that are like running into the lab and saying, okay, where are the meteorites? Do I get to look at them? Do I get to touch them? Can we get this out of the box? And that enthusiasm is impossible to teach somebody. So having that naturally, I think if you can sort of show somebody before an application that's who you are, then yeah, absolutely. So try and talk to people beforehand if you can, one way or another.
Oh, fantastic. Well, thank you so much for your time this evening, Natasha. You've been absolutely fantastic. You've inspired me. I want to become an expert in meteorites.
You can do. There's lots of meteorites to go around.
Okay, well, thank you very much, everyone, for watching as well. Don't forget, we have got these Q&As going on all week during our Takeover week. You can contact us on Twitter at UK Space Academy, or you can go to our website, nationalspaceacademy.org, and submit your questions there. Thank you very much for all of our wonderful comments and questions as well. Really enjoyed this evening. Thank you very much once again, Natasha.
You're welcome.
See you all tomorrow. Ended.
Yay.